Today we are learning about acid and bases, more the conjugates. How do they congregate? We have the Bronson-Lowry acid is, remember, a proton donor. The Lowry base is a proton acceptor. Remember, it's opposite of Lewis. We have the base, which is NH3. The acid, which, yes, water can be considered an acid, will produce the conjugate acid by putting a proton on the NH3, and the conjugate base by removing the proton from your acid to your base. And that becomes your acid. And then when you remove that proton, that becomes your base. Conjugate acid-base pairs. The species, conjugate base, the species remain after an acid has transferred its proton. Lost the H plus from the acid. Conjugate acid, the species...
Ms. Barrett, would you please call the B office? Ms. Barrett, call the B office.
The species produced after base has accepted a proton. The acid accepts the proton, the base loses the proton. Which we represent protons as H plus. Okay, acid. It's conjugate base. You see how the CO minus, that H just goes away and it becomes a minus. And O2 minus, you notice the trend. OH minus, you just get rid of a hydrogen and that will be your conjugate base. If it already is NH4 plus, it would just become a neutral NH3. Go ahead and write these down. This is number 1. Okay, now you go from the base to the conjugate acid. You have NH3. That becomes, you add a proton, it becomes NH4 plus. HSO4 negative becomes H2SO4. H2O, you add a hydrogen, becomes H3O plus. H2PO3 minus becomes H3PO3. OH negative, you just add the proton, becomes H2O. Go ahead and write this down. This is number 2. Okay, now when we look at the reaction, the H from the chlorine will attach over here. So, is this a double replacement or a synthesis or a single replacement or combustion? That's what you have to be asking yourself. What type of reaction is this? The H will move over here, so it will H3O plus with CO minus. Over here will be NH3, H2O. The H will move over to NH3 to produce the OH negative, so the base now becomes the acid. The acid now becomes the base. Products are referred to as conjugates. So the products are the conjugates. Each acid produces a conjugate base. So when you have an acid in Bronson-Lowry, you will have a conjugate base. If you have a base, you will have a conjugate acid. That's all it means. This is your acid and bases. Over here is your conjugate acid and bases. Okay, identify the acid and base. So, remember, your acid plus H2O will conjugate acid, conjugate base. This becomes your base, this becomes your acid. This becomes your base, this becomes your acid. So, go ahead and write these down. And this is number 3. Number 3. Amphoteric solutions. A chemical compound able to react with both an acid and a base is amphoteric. Water is amphoteric. It behaves sometimes like an acid and sometimes like a base. So it's interchangeable. You see here how this can represent the acid or the base, depending on what you have with it. If you have an acid with it, it counts as the base. If you have a base with it, it will be the acid. And that is the end.